Again, good morning all. So we'll continue our lecture on the basics of mechanics of solids. So in the last lecture I told about what is solid mechanics and its parts. So today I will just briefly introduce you the subjects or the topics that you are dealing with in case of solid mechanics. Okay, so basically solid mechanics, I told you that it's the study of forces and motions, right? And for in case of solids or in a deformable body. So we will be dealing with all sorts of applications which happens when a force is acted on an object and if it is deformed. What are all factors are internally or externally occurring? That factors we will be learning on that. So our first module is mainly based on stress, strain, these things. You might have heard about this stress and strain. What do you mean by stress? It's force per area, right? You might have heard in your +2 class, stress is nothing but force per area. So for that sort of stress, there will be many sorts of, that stress comes from force. I told in the last lecture that there is a cause and there is an effect and there will be a relation between these. There is a cause, there is an effect, and you need to find out the relation between these two, cause as well as effect, right? So here also you have the cause is always mainly force, okay, and this effect is deformation, right? So in the last lecture itself I told that the main cause is force as well as effect which is dealing with is the deformation of an object. So when the force is applied, there is a deformation, right? So this deformation will be having some inherent properties or internal properties which are related. Such a property is stress. One of these properties is stress, right? Stress is force per area. You got one relation, right? Stress equal to force per area. You got one relation. So this is what is happening in mechanics of solids. You will be relating all those terms which happens due to a cause which is force, and you will be analyzing with the help of some laws and all these things. So in mainly the first module we will be dealing with stress. The first part is stress, and it's not that a simple term or something like that. Stress is really long and there are many big concepts behind stress. Okay, so we'll be doing this stress. What happens if you apply some force on this? There will be some forces, stresses induced, right? So what sort of stress is that? In which all points, due to this application of this force, which all points on this body will show changes due to the stresses induced in this. Okay, all these sorts of minute things we will be learning on this first module itself. Actually, this stress and its detailing were studied only in advanced mechanics of solids for the previous batches. But here, for you people, there is no advanced mechanics of solids paper. But instead, you need to learn all these things in mechanics of solids itself, right? So stress and its terms, what all things will come when you talk about stress. You will be learning some laws. Hooke's law, you might have heard about Hooke's law. Stress by strain is equal to Hooke's law. Stress by strain is a constant. Stress by strain is a constant and is called as elastic modulus. Such moduluses, many constants like that you will be learning, and in a material what all stresses at each point what will be the stress, on what grade the stresses are changing, or stresses depends on what all things. These all things you will be learning in the first part of the first module. The same thing you will be learning about strain also. Almost the same method. The strain, what do you mean by strain? Change in length by original length. So strain is nothing but change in length by original length. So what happens if you apply some force? There will be stresses induced, as well as there can be some deformation, elongation can be happened. Okay, so initially if a bar is applied with force, say 10 Newton, initial length is 12 mm. This has increased its length to for 1 mm. Okay, so this has occurred due to this 10 Newton force. A small increase in the length has occurred. Okay, this change in length is 1 mm, right? Divided by the original length is called as strain. So this also you might have studied in your basic physics, right? I'll be detailing all these things in the next lectures when you come up with the when we start the module, first module. Okay, and the main point in the second module is one of the main point is MOS circle, and this is only for 2 dimensions. And one more thing, this stress and strain we will be learning in detail. That means in 3D. In 3D matrix you will be having stresses, and in X, Y and Z directions you will be learning all the 3-dimensional stresses. That means we will be representing it in matrix forms, right? That I'll tell you when I reach those topics. Okay, so module 1 is very vast and it takes time. It is very important. The basic things you need to know, you need to catch from module 1. So module 2, if you look, module 2 seems to be bigger, but it is better when compared to module 1. I'll say like that. So first of all, we will be learning some equilibrium equations. I told you that this mechanics of solids is mainly depending on analytical or problematic side. Okay, so you will be having a big equations. Everything will be there regarding stress, and this is just a continuation of first module. All these modules are, without knowing the first module you cannot learn 5, 4, 3, 2, anything. All are connected. So you need to go in this fashion itself. Okay, so we will be applying these basic concepts of stress in these equations. Okay, equilibrium equations and matrices will be involved in that. And the second part of second module is somewhat easy when compared to what we have learned, what we will be learning before that. Okay, so stresses in axially loaded bars. That means if you are having a bar like this and you are applying a force, okay, what will be the stress induced? Similarly, if there are 2 or 3 bars and you are applying force, what will be the stresses induced? What will be the elongation? What is the strain? What is stress? What is the elastic modulus? And those terms we will be dealing here. Okay, this is actually interesting part. And next is thermal stress. If you heat this object, what will be the stresses induced? And see, if you are heating this object, what happens? This can elongate, and if you stop its elongation somewhere around here, say here itself you are stopping. Say, I'll tell you an example regarding railway lines. Okay, this is an important problem that we could discuss. Interesting problem. You might have seen railway lines, they will be laid with gaps. Why? When the climate changes, this will expand as well as contract. So railway lines, when it is in summer, it tries to expand, right? Okay, iron will expand. So thermal stresses, how it expands. Okay, so what is the rate of expansion, how much distance it can expand, all these things you can. What is the distance that to be maintained between the railway lines? It's just an example. So these all things will be learning in case of thermal stresses. Okay. Now relation between moduluses. Now what do you mean by modulus? Stress by strain is equal to elastic modulus. Similarly, there will be more moduluses like that. You might have learned. I will refresh you when I reach there. Okay, you will already learn these terms when you study the first module itself. I'll be telling that sort of things first module itself, but the relation will be discussed in the second module. Okay, now if you consider the third module, the first part is entirely different. It's about torsion. What do you mean by torsion? Torsion, torque, twist, all these things. If you are applying a force, what is this? If you twist an object, what happens to it? There will be a torque experiencing. Okay, it's a twisting force. Torque is nothing but a twisting force. Torque is twisting force. Okay, so what happens when an object is twisted? What are all the stresses involved in it, strain involved in it? What is the material deformation? What does it happens? All these things are detailed in the part torsion. Okay, and next part is simple bending, right? This is also very important part, and it is the most, I would say this is the most easy and interesting part for mechanics of solids. Okay, shear force and bending moment diagram. So before that we need to know bending. If you apply force on an object, say this is a cantilever. I hope you know all these cantilever, or refresh the mechanics topics once again. Okay, so if I am applying a force in a cantilever, what happens? It shows bending, right? So how much will it bend? Or while bending, what all stresses are induced in it? Shear stresses will be there. So all these things. And bending, what is the structure of bending? So if it's a simply supported, you're applying some force here, what will be the total structure? How it will deform? All these things you'll be learning in case of simple bending. For symmetrical parts, you'll be having a simple bending equation, and based on that you can draw shear force and bending moment diagrams. This diagrams seems to be very important. Shear force, bending moment diagrams are very important. And next part is shear stress distribution. For every object, if a load is applied, there will be shear stress, right? So how it is distributed? In the load which is applied, the point at which the load is applied may be having high shear stress, or it will be having low shear stress, all these sorts of things. How it is distributed along, if I am applying a load here, okay, so how the shear stress is distributed in the whole thing. Here the point of application you will be having more stress, but in other parts the shear stress can vary. right? So in what fashion it varies. Okay, this is what I am going to explain in this shear stress distribution. Okay, now module 4 is, the first part is deflection. Okay, deflection is very, very important. So it's an application. The main thing you need to learn about simple bending and all. You need to find out how much. See, if I am applying a force like this is going to bend somewhere around here. Actually, physically, I need to know how much bending does it occur if I am applying this force. Okay, it is not so important what is the structure, but how much distance it is moving. Okay, and how much stress it can attain. All these things you can learn from deflection. Also for competitive exams also, mainly deflections, you need to find out the deflection part. Okay, the questions will be coming to find the deflection part. For that you need to know the basics of all these things, bending equations, all these things, right? And next part of module 4 is strain energy. Okay, strain energy is an interesting topic that you need to find out. In that, this Castigliano's, there are some theorems called Castigliano's theorem. Okay, this was a topic discussed in advanced mechanics of solids for the last year students, but here you need to learn this in mechanics of solids itself. Okay, so Castigliano's theorem, these are very simple problems, but it's interesting. Based on strain energy, there is a theorem suggested by Castigliano, and that theorem has to be known. Okay, and the final module is, it's not a small module. I just represented only these 2 points, that's all. Okay, so basically you have columns here. These columns, problems and all, somewhat simple, it's not a big deal. And theories of failure. Theories of failure is a fresh topic for mechanics of solid students. Basically, this comes under design of machine elements initially. For your seniors, this topic will be the base for design of machine elements 1, which has to be studied in 7th semester. But here you will be studying the basic theories of failure here itself. Okay, those are simple parts. You need to do some basic problems also regarding that. Okay, so this is the overview of our syllabus of mechanics of solids. Okay, so I'm reminding you once again, this subject is so much crucial for any competitive as well as any exams, not only for our final year exams or our engineering exams. It is very important. It is relevant for all the competitive as well as for interviews also. Main part of the questions will be based on the base of mechanics of solids. Okay, so this subject is so much crucial for you guys. Okay, also you need to know these basics when you go to your higher semesters. You should have a minimum knowledge of all these things if you do problems for higher semester papers. Okay, so we'll start the lecture in the next series, or the lectures will be started soon. In the next lecture we'll start with the stress. What do you mean by stress? What are its terms? What are the terms regarding? I'll be giving a great I'll be giving a good explanation of the real explanation for stress. Okay, similarly strain, all these things I'll be explaining. Okay, hope you're getting. Please come back to your mood, start your academics. Okay, all the best. Thank you.